Hi everybody, this is Mr. Wunsch, and this is your lesson on combining like terms. You're going to hear combining like terms a lot in algebra and pre-algebra concepts, and what it is, it's a way of simplifying an otherwise complex looking situation. It could be an expression or an equation. For example, if you look at this right here, this expression, at first it looks very complicated and you're not sure where to start. In the next minute and a half, you will learn what you need to know to make this look very, very simple. Let's go ahead and start really basic. How many shoes do you see here? Of course, almost every single person said 6. You immediately see that there are 6 shoes. What you don't see is 2 plus 2 plus 2. And the reason your brain tells you don't need to say it like that is because they're the same things. They're like terms. It would be obnoxious to tell somebody that you see 1 shoe plus 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 1 shoe. Of course not. You just combine them all together and say that you see 6 shoes because they all have the same label. If I were to throw something in there and I said, what do you see here? Almost everybody would say, well, I see 6 shoes, I see a water bottle, and I see a jumper cable. We could represent that with 6. S could stand for shoes. Then we see a water bottle. And then we see one set of jumper cables. Notice how I don't need the 1 before the variable when I'm writing it out like this. The 1 is just assumed and we don't have to write that, although it is not incorrect if you were to put it like that. Nobody said that they saw 8. And that's going to be a common algebra mistake a lot of people do. They're going to take items that aren't similar and try to add them together. When I said, what do you see here? Nobody said, oh, I see 8 shoes, or 8 water bottles, or 8 jumper cables, because it doesn't make sense. They're different things, so of course you can't combine them. Now let's look at some M&Ms. Let's pretend I just asked you the first question of how many total M&Ms are there. Let's pretend the color doesn't matter. You just need to decide how many M&Ms are there. Go ahead and pause the video right now while you count. Okay, if you've counted correctly, of course, you see there are 20 total M&Ms. Some of you were able to draw over the top or circle groups or whatever way you came up with it. It was fine, but you saw they were all one item. Let's look at the picture again now, and let's pretend color does matter. Let's say that an orange M&M is not the same as a blue M&M, and a brown M&M is not the same as a red, or any combination of that. Go ahead and pause the video now while you determine how many of each M&Ms there are. Okay, if you are anything like the way I did, you kind of broke them down like this. And because my brain thinks algebraically, I even went ahead and I put a letter for each M&M. So if I were to write this out and make it look like an algebra expression, I would see that there are 1, 2, 3, 4, 5, 6, 7. Whoa. I would see that there are 8. Here we go. E's. Plus, I can see the 3 blues, plus the 3 reds, plus the 3 yellows, plus a green, plus 2 brown. Now, there's no way I can simplify that any further because they don't mix. I can't add a yellow to the orange and say there's all of a sudden 9 oranges. I can't add the green to the red and say there are now 4 reds. They're different things, so we can't combine them. And as we go through this entire year, you need to keep that in mind. Try to think back to these M&Ms and understand that if they're different things, you can't add them to other things. Right now, let's say I were to add one more red M&M. Let's pretend that's a good red M&M there. Of course you're going to rewrite it and just say instead of 3 red now, you've got 4 red. Notice how I don't add it over here, I don't add it here, I don't add it here, to the green, or to the brown. You realize I don't add it there because it's not the same thing. They don't represent the same quantity of values. Alright, that's combining like terms. Let's go ahead and look back at the equation I flashed up there before. So the first thing I need you to do is go ahead and see if you can solve this right now. Press pause on this and go ahead and try to simplify it as far as you can. Pause now. Alright, we'll see how close you were able to get. The first thing I always do is I do my chop slashing. So chop slash there. Now I go through and I look for my common symbols. So I can see that I've got X's here, X's there. I can also see that I have Y's here and Y's there. And then my last thing, I can see that I've got a 10 halves right there. So now I just need to combine like terms. I take my 3x and my 14x, and I'm left with 17x's. And then I take my half y and my negative half y, which cancel out to 0. Then I go further and I look over here and I say 10 divided by 2. Well, that's the same as 5. So I just add my 5. The furthest we can break this down now is to 17x plus 5. I want you to go ahead and try this one now as well. Hit pause now. Okay, now let's see how well you did over here. The first thing we need to do is our chop slashes. Okay, now let's find our common like terms. So the first thing I see is 4 y's here, and I see an extra y over there. Then I see a negative 3 w's, and I see an 8 w's here. Then my last common like terms here, I see a 16 and a negative 7. Let's go ahead and pair them all up. 4 y's plus 1 more y gives me 5 y's. Negative 3 w's plus an 8 w gives me positive 5 w's. And a positive 16 plus a negative 7 right there gives me a positive 9. So the furthest I can break this down is to 5w plus 5y plus 9. And there you go. As simple as it is of combining like terms. Thank you.